low pressure center because of the thermal contrast between the cold and warm fronts. The center of this low pressure system will grow and evolve. These systems are responsible for the weather conditions in our temperate regions. By observing the evolution of a weather system from the ground, we can make predictions about how the weather is going to change and consequently better plan for those changes. What can we observe from the ground? The arrival of a warm front. A warm air mass will rise above a cold air mass because it is less dense. The warm front has an almost vertical slope and moves slowly. The ground temperature increases slightly. The arrival of a warm front is first noticeable by the formation of clouds at very high altitudes, such as cirrus or cirrostratus. Then, as the warm front advances, rain clouds will begin to form at lower altitudes. Then, the cold front moves in quickly, behind the slower moving warm front. The mass of cold air being denser, it undercuts the warm air, forcing it to rise. The warm air condenses quickly and abruptly, causing storm clouds such as cumulonimbus to form. The air mass becomes quite unstable. Ground level temperatures decrease. When a cold front catches up with a warm front, it's called an occluded front. After the cold front moves away, the sky clears up. Then, a high-pressure system, also known as an anticyclone, sets in. The front having passed, the sun's rays now are able to penetrate the clear skies and heat the ground, creating updrafts of air called thermals. Visibility is excellent. Cumulus clouds are present in the sky. This is the time for experienced cross-country pilots to fly. However, these conditions may not be suitable for inexperienced pilots and must be treated with a great deal of respect. By now, you should have an overall idea about the movement of air on a planetary scale. Let's now turn to micrometeorology, the motion and forces of air on a much smaller scale. Understanding certain micrometeorology principles is extremely important because they directly affect the quality and security of your flight. Your familiarity with the weather will increase with experience. Nevertheless, as with any discipline, you should be curious about it and you should already be observing your environment in order to better understand it, but also later to be capable of evaluating current and projected weather conditions so that you know when to fly and when to stay grounded. Now we know that the air we're flying through is in perpetual motion and that there is no such thing as perfectly calm air. Disturbed and chaotic air currents called turbulence can occur, as can more orderly updrafts of air called lift. Lift enables you to keep flying for long periods of time. There are two main types of lift. Dynamic lift is created as wind flows over hills and mountains. Thermal lift is caused by radiant heat emanating from the ground. First, let's look at what causes dynamic lift. When an air mass cannot go around an obstacle such as a mountain but is forced to pass over it instead, the wind that climbs up over the obstacle creates a dynamic lift. Unfortunately for us, all obstacles and the airstreams they generate do not create exploitable dynamic lift. In order to create good dynamic lift, three conditions are required. First off, the airstream must be as perpendicular as possible to the obstacle. Secondly, the wind mustn't blow too strongly, otherwise it'll become turbulent as it travels uphill. Lastly, the shape of the obstacle. The shape of the obstacle is essential because the air will always find the shortest means of overcoming the obstacle. In the case of this conical hill-shaped obstacle, the wind follows the most direct route around its sides. In the case of a sufficiently wide and reasonably high landform, the wind stream climbs over it and lift is produced just before its summit. Let's look at how an airstream advances uphill and downhill. It's important that you understand this phenomenon, not only to make better use of the lift, but also to avoid the hazardous areas. A lift originates on the windward side of the mount near its summit. The higher you ascend in the lift zone, the weaker the lift becomes. To take advantage of the lift, you should make figure 8 parallel to the ridge, making sure to turn with your back towards the elevated ground. On the leeward side, things are completely different. The airstream does not create upward lift, but rather downward moving air currents that are very turbulent. The further you descend into this zone, the stronger the downdraft becomes. The presence of turbulence makes flying in these areas extremely ill-advised. Flying through dynamic lift will result in your first long-lasting flights. Taking advantage of this kind of lift is not difficult. It will give you the chance to get used to piloting your wing so that you will be better prepared for thermal lift. Thermal lift is another way to make your flights last longer. Warm, invisible air masses of different sizes will lift and carry paragliders up into the clouds. We're not going to give you a detailed technical explanation on how to take advantage of a thermal lift, nor how to fly in thermal lift conditions. However, we do want to provide you with some essential information that will be useful to you later on. How are thermals formed? Remember back to the different energy transfers we discussed earlier? Thanks to radiant energy from the sun, the ground is heated up. It should be noted though that this depends on the terrain. For example, a ground covered with snow will reflect more than 3/4 of the radiant heat as opposed to absorbing it. Afterwards, the ground will conduct its accumulated heat to the air directly above it. That heated layer of air will become warmer than the air around it, and as it warms it becomes less dense and inevitably rises through convection. A difference of 2 degrees is all that's needed to make this pocket of warm air rise. If certain pressure and humidity conditions are reunited, a cumulus cloud will form at the top of the lift. As soon as the lift stops, the cloud is no longer supplied and it will eventually disappear. For paraglider pilots, the cumulus is the king of clouds. It is the sign of good flying conditions and above all, it indicates the presence of thermal lift. But there are also other clouds we need to be aware of. Distinguishing clouds is a difficult task because of the vast number of different observable cloud formations. This is why we're going to introduce you to the main clouds in each major family. Being able to recognize the clouds in the sky is very important before your takeoff, but also for anticipating the way the weather might evolve during your flight. Meteorologists have classified clouds according to 2 criteria: their altitude and their